Title of my talk today is Efforts at Raman Research Institute towards hunting for elusive signatures from the first stars. Saurabh mentioned about the signatures that we are looking for. As you can make out from the title, we assume that the receiver system Saras radiometer is already in place, and then it has gone through the laboratory, all evaluations and other things. Okay, so we need to take the radiometer, Saras radiometer to some place, deploy it, and then observe, collect data, come back and analyze. So where do we take it? Is a question. So what is the importance of a remote observing site? So Saurabh did refer to some pristine sites that that's a pristine site that is required, and then all the radio frequency interference, and then in this talk I'll give you an analogy of what happens with very strong radio frequency interference, and then once you have identified a site which is remote and then is not very far away from civilization. Just because it's far away from civilization doesn't mean that it is suitable for Saras kind of activities. So what is it that we look for in remote sites? So I'll be referring to that. And then we have recently, in the last year or so, we have visited a couple of interesting remote sites across the world, and for really to do frequency characterization of the site and see if it is suitable for Saras experiment, to deploy Saras. Okay, and then end with some challenges that we encountered. Of course, at the end, you would all really very quickly, really nicely note that radio astronomy activities does take you to very nice remote places. So it comes with its own challenges. So you'll be able to appreciate that as well. Okay. So we all work together in the laboratory called Distortion Lab. Okay, and then one of the major aims of the lab is where we continually design, develop, deploy, trial, and improve a spectral radiometer, learning from previous deployments, and then factoring in those whatever we understand from that, and then build a new system. That is one part. And the next part, like I mentioned, is we are always looking for potential observing sites where we can deploy. And potential observing sites, by that we mean which is radio quiet, relatively radio quiet, and then free of what we call as radio frequency interference that Saurabh referred to. So I'll be telling you more about this radio frequency interference. So the major activity, like is mentioned here, is we design and develop all the entire what we call as the Saras radiometer, right from antennas to analog receivers to digital receivers, and put them all together and then collect data and then come back and analyze. So basically we are looking at a frequency range of 40 to 200 megahertz. So what is the importance of a remote observing site for Saras? So Saurabh did mention about we are trying to detect an extremely weak signal of the order of a few tens, a few hundreds of millikelvin present in a background of order of 10 to the power 5 from galactic and extragalactic sources. As if this challenge itself was not sufficient, we have another problem, which is terrestrial man-made radio frequency interference. Okay, so by this what we mean is all the interference, radio frequency interference, which comes from FM radio broadcast, and then various communication systems, for example, airport radar or walkie-talkie, police communication, various things, and then emission from satellites, and then emission from certain lamps and lights, and then in addition to all these things, well, we are kind of complaining or cribbing about a lot of interference that falls within our band of interest, like this FM radio, satellite, airport, handheld receivers. This interference which comes from our own systems. Like for example, you have a processor. We had I showed you a picture of a laptop which is acquiring data. Okay. So the processor itself has a lot of clocks and then a lot of switching signals, control signals. They themselves radiate, and then we should not be confusing our signal of interest, and then we should not. They should not mimic our signal of interest. Okay. In the next few slides, I'll also tell you how we manage this particular thing, that is interference from our own receiver. So I just want to give you an analogy as to what happens, what is the effect of radio frequency interference from this. So what we understand is about less than 70 dB is something that is comfortable for humans. There's the sound of a normal conversation between people, and then less than 70 dB is safe. But if we just go beyond this, and then I'll just take example of a jet engine at 135 dB. The reason I take this is I'm sure most of us in this audience would have at least once visited the Aero India show, which happens not far away from here. And then it's so nice to see various kinds of fighter jets like Sukhoi or something like that. And then he's simply taxiing and going to the top of the runway. And then once he gets clearance to take off, once he revs up his engine, and then you can see that you will not be able to talk to your neighbor. Okay. So even if you are shouting, you will not be able to understand. So what it means is just as loud audio frequency signals interfere with speech comprehension in humans, loud radio frequency signals interfere with the normal operation of a sensitive Saras radio astronomy receiver. So by a sensitive radio astronomy receiver, it has been designed such that it's able to detect 1 part in 10 to the power 5. So it's extremely sensitive instrument, but if there is a very strong radio frequency interfering signal, at times it can be debilitating. Okay, so receivers can go bad. So this is the analogy. So Saras team is searching for a remote radio quiet observing site, so that Saras receiver can simply operate normally. Okay, so we are looking for a remote site. So what are the possible places, and then why is it that we want to be far away from civilization? And then it is because we are hoping that there will be minimum radio frequency interference at potential observing sites. The reason why we say it's hoping, because from our previous experience, we said just because it is remote, it doesn't mean that it is radio quiet or it's conducive to deploy Saras. Okay, so some of the places that we can visit is one of them is Andaman and Nicobar Islands towards the north, and then you can see that the population density is pretty low. Just for reference, I think Bangalore is about 11,000 per square kilometer, 11,000 people per square kilometer. So out of these 4 lakhs, maybe 40% of them stay in and around Port Blair, Sri Vijayapuram. And then if you go far away to Ladakh, where population density is much less, it's in single digits, low single digits. And then the reason why I've shown you these two is the international astronomy community is building a radio telescope. It's what's going to be the world's largest radio telescope called Square Kilometer Array, with a collecting area of about 1 square kilometer. And this coming up in the Western Australian desert area, and then you can see it's almost nothing. Very few people live here. So the low frequency part of this square kilometer array, it is coming up in Western Australia. The mid frequency part is coming in the Karoo region of South Africa. Okay, so we see that. So there is a reason why we want to be far away from civilization, hoping that it is conducive for Saras deployment and proper operation. Okay, so it's nice you can identify remote sites. Just because it is remote, is it conducive? So we need to, what we do is we need to carry out a frequency characterization of a potential site, observing site for Saras. So we ship our RFI recording system, okay, to the remote place, and then put it together. It basically consists of an antenna, which is something similar to this, which which picks up electromagnetic radiation, converts it to electrical signal. It's amplified by some preamplifier, and then through a long coaxial cable, it brings it to a post amplifier, another analyzer or spectrum or network analyzer like this, and then there's a recording system. The reason this set is enclosed in what is called a RF shielding enclosure. You remember I mentioned the processors inside and the network analyzer, all of them have clocks and switching signals and other stuff in them. So we don't want these signals to leak and then get into reach our antenna and then come back and be part of our system. Okay, so what to prevent that from happening, what we do is we put it in what is called as this, what you see is the black box here, it's a RF shielded enclosure. Okay, so this is the antenna is here, preamplifier is sitting right below antenna. There's a 10-meter coaxial cable bringing it to this electronics recording system which is inside this box. Because it's a remote site, we will not have access to power, we power it from using batteries which we carry it. Okay. So this picture is from a remote site near Diglipur in North Andamans, and then this is the spectrum. So by spectrum what I mean is on the x-axis here is frequency ranging from 5 megahertz to 500 megahertz, on the y-axis is power in dBm. So we find that except for this blip here which comes from a satellite, the rest of the band appears very nice, and then this is really one interesting place that we want to go, and then we have been there recently, and then we want to go there again and collect more data. So one of the items that was listed in the possible sources of radio frequency interference is lamp or light sources. So we went to another site in Andamans. So when the lights were off, this is how it looked, and when lights on the lamp, lights on this tall lamppost, when they were switched on, this is what it became. So especially some LED lamps, they generate unwanted emissions across the band of interest. So that's the reason why we need to be really away from all these and then as remote as possible. That's what we mean by pristine from the point of view of radio frequency interference. Okay. So this is just a video. I'll just draw your attention. Please focus on the left-hand side of this instrument. So after some time, we'll get the lights switched off one by one. Okay. So a commercial instrument is already struggling, which is supposed to be having a large dynamic range, which is supposed to measure large. So that's already struggling. So there's no way a sensitive instrument like Saras would survive in this. Survive meaning do the job that it is expected to do. Okay. So lights are switched off. And then we come back to thing. So it's much better. It's almost like the plot you see on the top left here. And then the ADCO range with the instrument was struggling, so that's gone. So we requested them to start switching on the lights one by one in the surrounding area, and then you can see things are going bad. And it will get back to this situation when especially the light on the tall lamp post when it comes on. So with a lot of these site characterization strips and other things, many of us have kind of graduated, if I may say that. Just looking at the first spectrum here, more or less we can estimate or assess what kind of a site it is. We don't really have to look for long-term data collection and things. So that's how it's back to now that once the lights are on, and then the system is again struggling, saying that it is ADCO range, which means it is going beyond its limit. Okay. So what it means is, even if a potential observing site is remote, its RFI characterization can throw surprises, just like you see here. So typically one of the requirements is we want to be away at least by few kilometers from such light sources. Okay. So we want to really go to remote sites. So one possible site is really this place called Svalbard archipelago in the Arctic region. And then it belongs to Norway. And then thanks to Saurabh, I got an opportunity to visit this place with the RFI characterization equipment about 6 to 8 months back. So this region is blown up here in this. So Longyearbyen is the administrative capital of the place, and this place is called Ny-Ålesund. This is the world's northernmost permanent settlement. There are a lot of research stations from about 11 or 12 countries and 20 different groups carrying out research activities, of which about 3 or 4 countries do that round the year. Okay, and then just for reference, Bangalore latitude is about 13 degrees north, and then about 77.5 degrees east is the longitude. So it almost swaps the positions. Latitude of Ny-Ålesund is of Svalbard is 74 to 81, of Ny-Ålesund is about 79 degrees north, and then longitude is about 10 degrees east. So we think we are really in a remote place. Okay. And again, one of our metrics is population density, and it is comparable to the Western Australian area, 0.04 persons per square kilometer. So I'll have some very interesting slide on Svalbard in the next few slides. Okay. So Ny-Ålesund, which is somewhere here, is about 1,200 kilometers from North Pole. Okay. So it is well within the Arctic Circle. This is the Arctic Circle. Arctic Circle has the latitude of around 66.3 degrees, 66 degrees 30 minutes. Okay. And then Ny-Ålesund is something like this. That's how it appears. There is a settlement area, a town area, and there are a lot of buildings here which belongs to various, it belongs to a company called Kings Bay, and then many research institutions from various countries, they have they have taken up some of the buildings here, and then where they carry out research, especially in study of climate change study, and then atmospheric sciences. And India has its permanent research station called Himadri here. Okay. So slightly more about Himadri. So because we have this Himadri station, we could go there and then have a base. And then it is India's permanent research station located in Ny-Ålesund, Svalbard. It has been operational since 2008. And scientific teams have traveled to Himadri only in summers. That was till the end of last year, that is about December 2023. Only April. That is because daylight was available during summers, and then when temperatures were above freezing point, and then people could go out and do their field experiments. So although automated observations continued during winter, field experiments were not possible. In 2023, India decided to maintain a year-long presence at Himadri and to become only the 4th country in the world to do so. So winter expeditions aim was to, they wanted to address the data deficiency during polar nights, especially in atmospheric sciences, space physics and biological sciences. So I had an opportunity to travel with a group of three other people to this place, and I was part of the, really proud to be part of first ever winter scientific Arctic expedition from India. Okay, and then this is the place where we were staying. This is Himadri station, and then I think I spent about 1 month here. I carried the RFI characterization equipment there, and then about 1.5 kilometers from this place, there's a laboratory called Gruvebada laboratory from Himadri is somewhere here. Okay, so it's about 1.2 kilometers from this Gruvebada. On a rooftop of this laboratory, we are set up this RFI recording system. I'll show pictures of them. I told you the Svalbard archipelago, there's some interesting facts about them. The 1920 treaty allowed Norwegian sovereignty, so it basically belongs to Norway. And then, sorry, is the world's northernmost permanent settlements. Although further north there are settlements, they are not permanent. So this is considered to be the world's northernmost permanent settlement. It is said that polar bears outnumber people. So there are about 2,500 odd people, and they expect more than approximately 3,000 polar bears. Okay, so king of Arctic. So due to harsh conditions, there are no trees or tall shrubs. Plants that grow here are less than 10 centimeter in height. And interesting, cats are banned in Svalbard, and then it is illegal to die in Svalbard, and giving birth is discouraged due to lack of medical facilities. And then what is called as civil polar night is when civil polar night is when sun is about 6 degrees below horizon. So it lasts from November to January, and then Svalbard, like all of us know, Norway is a land of midnight sun. You will also have between April and August, sun never sets almost. So these are pictures taken in New Olsen as soon as when we had moon, and then when it bathed New Olsen town in moonlight, that's when we could see the surrounding peaks. We had only seen them on Google Maps, so we got to see them because of this. And then this is moonlight reflected from the waters of Greenland Sea. Okay, it was just adjacent to New Olsen settlement, and these are some of the pictures from the settlement. So when you're up in Arctic, one of the major attractions is Northern Lights. Okay, so we got to see them almost every day, and then although these pictures really make it interesting, and then videos also that you might have seen, it makes it interesting. There's nothing like viewing them with this camera. So if that was about Svalbard and then a remote place. So like I mentioned, Ladakh is also a remote place. What you see in this region is a region called around Hanley. Okay, this is where the Indian Astronomical Observatory is present. It has its various telescopes there, and so if it was polar night and that was a challenge, and there was no sunlight and then cold temperatures, again here it's pretty cold. And then other challenge which comes in here is about altitude. It's on the average it's about 4,750 meters or around 15,000 feet. So the additional challenges which comes in here, I'll have a couple of slides on them later. So we call this as waterfall plot. Basically what it is saying is in the frequency range of our interest and as a function of time, how the interference, and then what is the strength, and whether it is continuous or like what you see here, for some time it is not present, again it's present, for some time it's off. So this gives us a bigger picture of strength of interference, and then whether it is continuous or periodic or sporadic, whatever it is. So this is from Hanley region, and then except for the known interference signals like from satellites, amateur band or the satellites, we see that in our band of interest is pretty clean, and then it is quite encouraging for us to deploy SARAS here and do science observations. So to find remote sites, at times we need to track at the altitude of 4,000 to 5,000 meters, and then maybe we took Robert Frost, the road not taken pretty seriously, I think. Okay, and then at this altitude where doing your normal chores is difficult, so we need to put things together and then be ready to deploy. And then we also had an opportunity to row at 16,000 feet in one of the lakes there. And after such a hard day, as you head back to your base station in Hanley, Indian Astronomical Observatory's guest house there, sometimes nature has its own way of removing all the whatever you have undergone through the entire day. So looking at such wonderful events, it's really nice that we could witness such things. So maybe Saras is the only CD, the Cosmic Dawn EOR experiment in the world that has been deployed at such a high altitude. Okay. So you may be wondering why this pulse oximeter, which became so famous or infamous, depending on how you see during COVID time. The reason why we have this picture is, the reason is this. So at sea level, if the percentage of oxygen in the air is about 20.9 or say 21%, as you go to the peaks of Hanley and then deploy your instrument, Saras equipment there at around 16,000 feet, it almost reduces by half. Okay, so you are basically struggling to, the body is struggling to get the required oxygen. So as soon as you go there or even reach these heights, you can feel your heart is pounding away, and then trying to supply the oxygen so that you don't pass out. And then we have seen people, and then we have had people who have struggled, and then that's the reason why we routinely keep monitoring our SpO2 and then heartbeat rate and other things. So that's the reason why I included this picture here, which is misfit if you are thinking that way. So if Northern Lights is an attraction in Svalbard, given its altitude, Hanley region, like many of you would know that India's first dark sky reserve is in Hanley. Okay, so we like sort of briefly mentioned that you get to see some of the best skies from this place. And then this is a picture from Dorje Angchuk, an award-winning astrophotographer from Indian Astronomical Observatory, Hanley. And then this is light within our kitchen tent where we had deployed. And then this is our vehicle here. And then our other deployment gear, they're all here, antennas and our tents where we stayed. So this is such a wonderful thing. And we almost get to see this surreal sky, especially coming from Bangalore. To see such things is really fantastic. Okay, so that was about cold desert, Svalbard, remote place, and then something familiar, it is Andaman and Nicobar Islands. So when you go there, it is more like you are somewhere traveling somewhere in Western Ghats, something like that, with a lot of greenery, forests, and then turquoise water of Andaman Sea on one side and Bay of Bengal on the other side. So this is one place in a place close to Diglipur in North Andamans where we had deployed recently. So this is the team putting Saras units together, and then Saurabh and I were trying to figure out in this lake which is the best place to deploy our antenna. So it's deployed, and then antenna collects this electromagnetic signal, converts them to electrical signal, and then there is the analog receiver which amplifies and does signal conditioning, and then there is this fiber which brings the signal over this fiber to the digital backend unit which is on the shore, about 150 meters, 125 or 150 meters from shore. So then there is this, we are checking out antenna for evaluating its performance, and then the digital receiver is in place. Okay, so when everything is ready, so when we want to do this, this fellow comes out saying, okay, you're trespassing. So like you can see my hand here, digital receiver, which basically is the master controller of the entire Saras radio meter. So when you start this, you can control all the switching in the analog receiver and other things. So the control signals go over those fibers, and then analog signal is brought back, it digitized, and data is collected in a laptop which is here in the top tray here. So this was left open. So we quickly close this, zip the tent, and then try to get rid of that. Okay, so this is all done, and it was monsoon time. There were already a couple of rains which had already come in that region, and that is when we understood that from locals that when all the snakes come out of the forest and then start moving all over the place. Okay, so this we understood was an Andaman crate, and then there was a doctor who was visiting, a medical doctor who was visiting the site, and then he kind of warned us, like, get bitten by any snake, don't worry, I'll send you back to Bangalore safely, but not this guy, Andaman crate. So if you're bitten by this, please take a phone call to have the last conversation with your near dear ones, and then say goodbye to life. Okay. So they did not have antivenom there. Okay. Okay. So you survive. Sorry. You survive all these, and then come back to your room to rest, and then this guy was my roommate, giant Andaman centipede. So he would simply be walking all over, crawling all over the place, and then maybe because our guest house was at the edge of a forest, and then this was his home, and then again I was kind of trespassing. I was occupying his place. So not knowing what to do, I simply taped the gap between door and the floor just to be safe. We understand again the local story is that it's extremely painful when it bites you, although not fatal. Okay, so you need anesthesia in the area where it is bitten. So the best is mix salt and kerosene and then apply. That's the anesthetic to reduce your pain or something like that. Okay. So very interesting and challenging. Each place, whether it is the remote Svalbard or Ladakh or Andaman, each one in addition to challenges of radio frequency interference and then mitigation and then deploying SARAS, collecting data, these are additional challenges, very interesting ones that you encounter. Okay. So this slide is, let's look at the date, it is around 6th January. Okay. So I told you that it was December, January when I was in Svalbard, and then it was polar night. As you can see from this picture, the RFI, the antenna for RFI collection is, it was deployed on the rooftop of the Gruvebada lab there. And then just beneath this antenna here in the room, we have the data collection recording system, the RFI recording system, along with the battery there, which is powering the electronics inside, and the shielded enclosure, which I referred to earlier. Okay. So how does it feel to be out there? I think this video is just to give you a flavor of how it feels to be. So a couple of them have bright headlamps there, and then they have what they call as high-vis shirt there, so that when they're walking in New Ulsan town, vehicles don't hit them. They have very bright reflective garment there, high-vis. So these two people from Kings Bay, we are trying to put the antenna together and then make the connection from antenna to the preamplifier, and then use the 10-meter cable and then bring signal to this place. It is coming through this window here, and then antenna is on top of this, on the roof of this block here. So I want to draw your attention is, just for a moment, if you can see the background, it's very dark. Okay. So if we were to switch off all the headlights there, it's pitch dark. Believe me, I think the video, there's an audio here where a colleague of mine is cautioning me, it's very slippery slope there. And then if you were to just slip or fall from this place, you would be dropping down about 12 to 15 feet and then into snow. Okay, so we need to be extremely careful. And then you can see these two people are just making sure that, and then it's very strong winds and snow, and just making sure that the antenna is not carried away by wind, even though it's a heavy antenna. Okay. And this is the guy who is making this video. His, you can see when he just turns away, it's so dark in the background. And then if you see here, time is 1:45 in the afternoon. So that's what polar night is. That's a challenge that comes with. You can see on the right side, it's so dark. So there are a lot of people, newspapers from here, and then various science journals who are getting in touch with me, saying that how was their experience and things. Everyone said, please share nice pictures. What picture do I share from here? And then with one of them, I simply said, okay, I had a video thing. We have very good internet connection here, a very high speed internet connection in New Ulsan. And then I told them, I'll just switch off the lights in this laboratory. And then said, sir, are you there? They asked me. So they could not even see that, they could not even make out that I was there. It was so dark. Like you would expect, it is a bit, it's quite challenging because to make all the connections, if you may just recall the block diagram I showed, there was a filter just before the preamplifier. So we need to keep changing filters and then collect data. So there's no way you can do the connections with your gloves on. You have to remove this, and at the end, I had first degree frostbite after this. That's okay. So the 10-meter cable is being sent down so that it can be collected from here and then interfaced with the recording system. Okay, maybe I'll stop that. I was just joking with Subbu. If you thought that, okay, you're a lucky guy, you went to such nice places, you got to see auroras and other things. So I just want to draw your attention to this. Okay, average temperatures during our about 28-30 days of stay there was about -15 to -20 degrees. Just one day, I think 5th of January, with wind chill temperature, it went to -40.5. So given that the temperature is generally in Bangalore is going up every summer, so it's more or less a sign change. So I should also be talking about this. We did manage to get, do the frequency characterization of the site, and then this is again a waterfall plot from Grueva lab data, the data that we have collected. And then the quick conclusion from this is in the frequency range 100 to 200 megahertz, which we call as upper band for SARAS operation. That is very encouraging. We do not notice any strong out of band interference on either side of that. But for this one strong signal at 172 megahertz, so this 172 megahertz, it ranges from 167 to 172. This is something that everyone who is staying in New Ulsan has to use it. So the moment you step out of your station, and then if you're going for field experiment or something, you need to carry that walkie-talkie so that if there's any emergency, you will be able to contact your station and then get help. And also there is the equivalent of emergency button. You press that, there is always one guy 24/7 who will come and help you if you are stuck somewhere. Your vehicle is, you need to be driving yourself from Himadri to Grueva lab, you need to be on your own. So if there is any problem, you can, worst case, call the emergency guy and he'll come and rescue you if you are stuck. So the conclusion is RFI scenario is acceptable for SARAS science deployment, and then if everything goes well, the team should be there end of the year, December or January. So I think with this, I'll conclude. Thanks for your time and patience. Hope I was able to give you a flavor for how these deployments go in various remote places. So although it is interesting, a lot of challenges involved in terms of working conditions as well as other things that I mentioned. That's it. Thank you. Thank you.